Section 2, Unit 4, Precision Measurement. Precision measurement. Measurement of tolerances tighter than 1/64th or 1/100th of an inch, half a millimeter or 1 degree. Semi-precision tools are not adequate. What is precision measurement? English measurements usually between 1/1000th or 1/10th of a thousandth of an inch. SI metric measurements is 0.01 and 0.002 millimeters. Angular accuracy is 5 minutes or 1/12th of a degree, and language of precision dimensions. Sizes in a language of machining. So examples of sizes using the machine language is 1.245 is 1 inch 245 thousandths or just 1 inch 245. 0.137 is 137 thousandths or just 137. 0.7588 is 758 and 8 tenths. 3.25 is 3 inches 250 thousandths or just 3 inches 250. 0.1 is 100 thousandths or just 100, and 0.32 320 thousandths or just 320. 0.2204 is 220 and 4 tenths. Precision measuring tools are delicate and are expensive. Care must be taken during use and storage. Calibration, verifying accuracy of a measuring tool. Most precision tools need regular calibration and may be part of an overall calibration plan. Check for flatness. Place across the surface. If there is space between it and the surface is not flat. See examples of straight edges. Comparative measurements against known sizes. Thickness gauges, pin or plug gauges, ring gauges, and snap gauges. And there's an example of a thickness gauge. A set of pin gauges in 0.001 or 1 thou increments from 11 thou to 60 thou. Gauge classes. Class ZZ is the least accurate, all the way to class XXX, which is the most accurate. A go-no-go plug gauge purchased to check a particular hole size. Note that the go member is longer than the no-go member. That is to keep it where you understand. It's just a quick reference, I guess you could say. And 2 typical go-no-go thread gauges. The go member is either marked as green or is longer than the no-go member, just like that in a plain plug gauge. A step on the front of a taper plug gauge can indicate the go and no-go limits. If the end of the part is to be checked is between the two end surfaces, the part is within tolerances. Go and no-go plain ring gauges. Note the groove around the circumference to identify the go and no-go gauge. So that would be the go, and that would be the no-go. And again, go and no-go plain ring gauges. Note the groove around the circumference to identify the no-go gauge. So again, this will be the go gauge, and this will be the no-go. 2 styles of snap ring gauges, or snap gauges. The outer anvils of the snap gauges are set to the go limit and should always pass over the part being checked. If they do not pass, the part is too large. The inner anvils are set to the no-go limit and should not pass over the part. If they do, the part is too small. Surface plates. Flat plate used as accurate reference surface for other precision tools. Most are made of granite, 3 different grades of flatness. And there's some examples. More precise, or solid square is more precise than adjustable squares, available in a wide variety of sizes. Solid squares, checking two surfaces for square or perpendicularity. With a solid square, the light showing between the part and the blade at the inner corner indicates the two surfaces are at a square. So you can see that it's touching here, but you got a gap here. So therefore, it's more of an obtuse angle than square. Checking the amount of perpendicularity area. So you can see how he's got it up against it, and there's shims going on the top, but it won't go on bottom. Accurately, or gauge block grades and other tolerances. Accurately sized blocks for inspection or testing accuracy of other tools. Available in different grades of accuracy. Different sized blocks can be rung together, called gauge block builds. When creating, the fewest number of blocks should be used. So here's a tolerance in millionths of an inch for each gauge block grade. So grade 00 is plus 4 minus 4 millionths. And grade AS2 is plus 24 minus 24 millionths. Block sizes of an 88-piece inch base gauge block set. So here's you a sample of what would come in a 88-piece gauge block set. Alright, steps for ringing gauge blocks together. Use this process, virtually any size build can be created. So on the rectangular ones, you'll slide it perpendicular, make a plus sign with it, and rotate it until positioned on top of each other. And same way with the square. What you are doing here is you're ringing all of the air out from between the two blocks. They're not magnetic, but if done correctly, they will actually stick together like they are, because there's no air in between it. Selecting gauge blocks build for a build. Alright, so if your build size is 1.6453, you select and subtract the first block. So you would work from right to left. So you'd want to get rid of this 3 first. Well, in that build that we showed earlier, you had a 0.1003 block. So now, what you're remaining is 1.545. So now you're trying to get rid of the 5 or the 45. So now you can do 0.145 block. So now you got 1.4, you use a 0.4 block, now you got an inch and you use the 1 inch block. When 0 is reached, build is complete. Vernier measuring tools contain main scale and secondary sliding scale called the vernier scale. Types include calipers, height gauges, depth gauges, gear tooth calipers, and protractors. Linear tools available in either a 25 or 50 part vernier scale. Line on the vernier scale aligns with the main scale. So I know this sounds confusing, but it's not as bad as you think. So parts of vernier caliper. So you got the internal main scale, the external main scale. Of course, here's your jaws and the nibs. The nibs are the very tip of it that will measure the internal measurements. You got the external vernier scale and the internal vernier scale, which is the top and bottom part. Of course, these are your locks, your fine adjustment, and your beam. There's a vernier depth gauge, a vernier height gauge. A vernier gear tooth caliper measures gear tooth width at a present depth. Note the vertical and horizontal scales. Alright, so if we're reading this, so here's 0 inch, here's 1 inch, 2 inch, and so on. But you're going off of this 0. So each one of these lines measures whatever it is written here. In this case, it is 25. So you can see that this line is right before this first line. The 0 is before the first line, so you will not add any of these 25s to it. So it will be 0.0 and then it's showing this arrow here that the 21 lines up. So on A, the answer would be 0.021. Alright, on B, you see how this 0 is after this third line. Like I said, each one of these lines is 25 thousandths. So you got 25, 50, 75 thousandths because it's after this third line. So right now you got 0.0 because it's before this first one, 0.075. But you add this 11 that's lined up here. So 75 plus 11 is 86. So for B, the answer would be 0.086. On C, you can see the 0 is still before this 1 inch mark, so it's going to be 0 point. But the 0 is after the 5, so it would be 0.5. The line, it looks like it's before the third one, so you got 2. So it's 50 plus whatever lines up here, which is the 6. So it'd be 50 plus 6, so 56. So the overall would be 0.556. And D, you can see here that the 0 is after the 1 inch mark. So it automatically tells you it's 1 point. It's before this 1, so it'd be 1.0. It's after the first line, so you got 25 plus, looks like 15. So that's 40. So 1.040. That would be your D. And this is the same thing, except on this one, the scale is 50. So you only got one line in between the 100 thousandths marks. So we'll do A and then we'll continue on. But, so we're looking at 0. It's before the 1 inch mark. So we're going to say it's 0 point. It's after this 6. So 0.6. It's before this line, so 0.6. But you just add the 35 to it. So 0.635. That's for the outside measurement. Now, if we were measuring a hole and this is still the same thing, then here is where you would measure that. So again, you would look at the 0, but this instance, it's after the 3. So 3 point, this 1 is, or the 0 is after the 1, so 3.1. It looks like it before the 50 mark, so we're going to say 3.149. It's kind of hard to see there, but 3.149 is going to be your answer for that one. Alright, vernier measuring tools again. A sample reading of a 25 thou part metric vernier scale, so it's actually going to go through. Alright, so there's your 0. It's after the 20 mark, so 20 millimeters. It's each one of these lines is 50, and then so 650. So 1, 2, 3, 4, 5, 6, 6.5. So it shows you that. It lines up with the 0.24. So your total measurement would be 26.74 millimeters. A sample reading using a 50 part metric vernier scale. Same thing. So your 0 is after your 23. So 23, it lines up with a 94. So 23.94. Some uses of a vernier protractor. A sample vernier protractor reading, the whole degree reading is 50. Since the degree graduations are increasing, moving to the left, read the left side of the vernier scale. The 20-minute graduation aligns. So the full rating is